In recent years, wearable technology has become increasingly ubiquitous in our society. Most of the widely available wearable tech options are focused on providing some utility, such as collecting health data like the Fitbit or Oura Ring, or increasing access to smartphone functions like the Apple Watch. These devices all have limited customization options and do not provide sufficient avenues for the wearer to express their individuality. Due to these limitations, there exists a market for wearable digital technology that exists purely for the sake of style and self-expression. These bold electronic accessories used to be reserved for the realms of festival wear and costuming, but recently they have been slowly entering the mainstream fashion consciousness. To draw inspiration for our project, we looked to electronic accessories that are currently commercially available. The festival wear company, Neon Cowboys, has a few electronic accessories in this area, such as their LED face jewelry and light-up bolo tie. The former utilizes single-color LED strips in a few shape and color options that are worn directly on the skin using an adhesive and powered by an external, non-rechargeable CR2032 coin battery, and the latter uses EL wire powered by a large rechargeable inline battery pack. Neither of these devices have color-changing options or wireless control. With our project, we aim to design a digital earring that is wirelessly customizable via Bluetooth using a mobile application. This device would have a variety of use cases, from daily jewelry to clubwear for people who want an elevated accessory that provides near-infinite customization options.
Our hardware is the earring itself, and to enable our concept of operation, we want to enable wireless communication between the hardware and the phone. We also want the hardware to serve as the display unit of the system. Therefore, we wanted to use a microcontroller that has on-chip Bluetooth functionality. So we initially chose STM32WB55 to display beautiful patterns. We chose the dot star LED matrix, which is an RGB display and it's pixel addressable. We initially wanted to design a PCB to let the microcontroller fit perfectly with the LED matrix, but we experienced significant difficulty in designing and manufacturing a Bluetooth PCB, so we switched to using Adafruit's Feather M0 microcontroller board, which comes with a Bluetooth module. What being compromised here in using the Feather M0 board is the size of the earring and the fitting between the microcontroller board and the display. Because the Feather M0 board is only 4 cm square larger than the display, we deem this compromisation in size acceptable.
To control the device, we decided to develop an iOS application. We used SwiftUI for iOS 16 to develop the user interface, and we stored user data with the SQLite database. To implement the wireless connection component, we utilized the iOS Core Bluetooth framework. After launching the app, users will see a Bluetooth connection page. Landing on this page will direct an instance of Core Bluetooth's CB Central Manager to scan for nearby CyberJewelry devices. Any detected devices will appear at the bottom of the screen. After selecting a device, the users will reach the device home page. Here, they will see a summary of information about the device. Using the toolbar at the bottom of the screen, the user can access their design library, where they can choose from one of their saved designs. Or, by clicking the button at the top right corner, users can create a new design. The design edit screen features an interactive layout representing the LED matrix embedded in the earring. The user can tap on one or more of the cells to edit the display properties of the corresponding dot star LEDs on the device. By clicking the Hue tab at the bottom, the user may adjust the color and brightness of each LED. Additionally, the Motion tab provides the user with preset movement options. Selecting the Reset button in the top left-hand corner will reset the design back to its last saved state. Finally, the user can select the button in the top right corner of the Design Edit page to save the current design to their library and upload the design to the CyberJewelry device. This shows our final architecture for the device. It uses GATT services and characteristics with the Feather microcontroller to communicate with iOS Core Bluetooth and control the dot star matrix.
Our final hardware has the Feather M0 and the display soldered very closely together with a battery in the middle of the two as well as a power switch tied to the back. This image shows the hardware with all the components exposed. Before we putting together this final version of the hardware, we also previously built a more simplified version with the battery stick to the back. This version doesn't have a power switch.
In this clip, you can see us doing some early testing with the earring. At this stage, we still see a little bit of latency, and we're only sending single color patterns over Bluetooth. Here, we have resolved the issues with sending multicolor patterns, and the device responds much quicker.